Question. Why is nitric acid a strong acid? And we can answer this with Lewis structures. First thing is what's the formula for nitric acid? Anybody know? Or if you had to take a guess.
HNO3.
Yep, HNO3. Okay. Now, when we say strong acid, what do we mean by acid strength? Yep, we mean the ability to dissociate. So what's this going to dissociate into? H plus and what else? Yep. Okay, we know that this happens in nature. It splits apart. You guys measured conductivity values for this stuff. Why does this happen? The reason is it has to deal with resonance. Resonance can help us explain. Let's draw the Lewis structure of NO3 minus, that nitrate anion. Okay, so how many valence electrons do we need for the nitrogen? Yep, 5 plus. How many for each of the oxygens? Yep, and then we got plus, what else do we need? Yep, 1 for that negative charge up there. What is the total number of valence electrons?
24.
Yep, 24. Okay, looking at this, which element is the central atom? Nitrogen, yep. Okay, let's start plunking valence electrons around. Which element are we going to start with? Oxygen, yep, it's more electronegative. Let's do that. Okay, we've run out of valence electrons. Formal charges, we need formal charges on this molecule. What do we got? Formal charge on this oxygen? Yep, same thing with this guy and that guy, right? Okay. What's the formal charge on the nitrogen then? Yep, +2. Okay. This is a plausible Lewis structure, but it's not a good Lewis structure, right? What would you suggest to make it better?
Make a double bond?
Okay, double bonds. Swing them down in. We do that. We get this, but we need new formal charges, right? Formal charge on this oxygen, 0. This oxygen, -1. Same thing for this guy, right? What about that nitrogen? +1. Okay. Can we improve this Lewis structure in any way?
No, because you can't make any more double bonds with N because its octet is filled.
Exactly. I was trying to catch you to get you guys to slip up and you did. Good work. Okay, but so we can't do any better. If this were, I don't know, let's say like phosphorus or sulfur, we could add another double bond because it can handle an expanded octet. But nitrogen's in that second row and it has to follow that octet rule, right? So we're stuck with this one. Is this the only Lewis structure we could draw? Yeah, we can move around the double bonds. We can, I don't know, which one do you want to have a double bond? Okay, bottom one. Minus, plus, minus. Is that the only one? But we could have another one. In this case, let's move it to the left, right? Okay, so there are all of these resonance forms, right? What do we know about resonance and stability? Yep, the more resonance structures you can possibly draw, the more stable it is. The reason for that is this charge gets smeared out across all of the atoms in the molecule. So instead of really this oxygen and this oxygen having a -1 charge, they have a value that's a little bit less because it actually spreads to this oxygen too, right? All of these structures are happening at once. So the molecule is kind of like an in-between state of all of these things. So the reason that this is such a strong acid, that anion is stable. The NO3 anion is stabilized via resonance. And because you can draw a bunch of resonance structures, it means the system is more stable. Does that make sense? That is a huge topic when you get to organic chemistry. And it rationalizes a lot of stuff that you'll see in Gen Chem too. Okay. All right, any questions about that? Everybody feel like they could draw